Alright gamers, welcome back to another AI video. We're talking a lot more about AI in the future, in the coming videos. But in this video in particular, I want to talk about something that I call the AI verification problem. The AI verification problem is basically in relation, specifically we're talking about LLMs, but this is also true for other kinds of AI, and you'll sort of see what I mean. So the thing about the AI verification problem is just that when you prompt an AI and you get an answer, you're dealing with a probabilistic machine. Right, so there's an aspect of non-determinism here, and this effectively is what causes this issue. So the problem is how can you verify the answer from an AI in a way that's more efficient than asking the question, basically? Or more specifically, the AI verification problem comes about by trying to balance this idea of you could ask the AI this question or you could do the problem yourself. And sometimes, even if you ask it the question, it gives you an answer. Verifying that the question is correct takes more effort or equal effort as just doing the problem yourself, right? So when is this really an issue? Think about any time you prompt an LLM, right? You prompt an AI agent or something like this to do something. When you get the answer, you need to think, well, how can I know if this is a good answer? How do I verify it? So let's take a problem like summarizing. So if I ask the AI to summarize a paper, how can I verify that the summary is in fact accurate? Well, the only way to do that is basically by reading the entire paper itself, right? So verifying the answer to the problem is not as efficient, or it's not any more efficient than just solving it by myself. Here's another one: verifying that AI code doesn't contain any bugs. So this one is related to a thing that's called Rice's theorem. Effectively, in general, semantic questions about programming languages are undecidable, which effectively means that there is no general general algorithm, efficient or not, that can look at a piece of code and give you semantic information. So, a question like, does this code contain a bug? There are, of course, syntactical bugs, logical bugs, but then there's, of course, bad bugs that have like semantic content to them. There's no general algorithm that'll give you a solution in every case, right? So you gotta approach every code base separately. You can find the answer, but it's gonna take a lot of effort. And you got to approach this separately. And so verifying that the code is bug-free is going to take a lot of effort. And verifying that someone else's code has bugs is way harder than verifying that your own code has bugs. Let's give it a day, come back, read it again. You can read it with fresh eyes, but at least you have an understanding of why the code was written. If you look at AI code, you don't know why it made the decisions it did. It's a little bit harder to debug these things. Now, in terms of time, yeah, maybe it saves you a bunch of time in writing, but for critical infrastructure, you do need to make sure that the code is safe, and verifying that safety is hard. Another one, and this is my favorite actually, checking if a piece of text is written by AI or not. And this is the same for video as well. How do you know that the AI didn't make a mistake? Like, you got to control for false negatives and false positives. So, how do you know that a human-based text is actually AI or not? And we'll tell you, oh, this is human, oh, this is AI. But how do you know if it says it's human, how do you know it's AI text and it's failed? And if it says it's AI, how do you know it's actually human text and it failed to detect that, right? So how do you deal with that verification? You can't verify the answer. The answer is definitely not like, if you try to give me the answer that, oh yeah, the answer is you just ask a stronger AI to verify the answer. The other AI is like, if you think that's your answer, then you've missed the point of the problem, right? The problem is that LLM is going to have its own error rate, and then now the errors are compounding. How do you know that this other LLM is wrong? What is that? Was the probability of that occurring? You don't know. But if you take the time to work through the answers yourself, like you can come up with some sort of deductive argument for why it's wrong and this sort of thing. But on its face, just taking the AI answer, you can't verify it. And for a lot of problems, the AI, like, verifying that the AI is actually correct is going to be a lot harder than just doing what you wanted. Now, there's some cases where this doesn't matter. So for example, if I say, oh, LLM, can you just write me a markdown file that has these things? There aren't any verifiable objectives. Like, if there's no right or wrong way to do something, and it's like, just write a template for me, you're going to be overwriting that template anyway. So it doesn't matter if there's spelling mistakes or if there's some issue or it's formatting issues or something like this, right? The point is, it just saves you a bunch of work. So that effectively is, I would say a good use of AI, because it kind of bypasses this fundamental verification problem. Another one is almost like a database query. Give it sort of some unstructured language, and you just say, oh, can you give me things that have this kind of property that I can't quite describe? Query this sort of database. The LLM can go and find those things, and then you can easily verify if they exist in the database or not. I guess an example of this is like, oh, can you give me, suppose you're a researcher, and I'm a master's student, so I do research. It's like, oh, can you give me 5 papers that talk about this certain topic? Oh, well, ChatGPT or whatever, Claude can go and give you, oh, yeah, certainly, here are 5 papers that talk about this topic in this sort of way and have these sorts of considerations. Then all I can do is I can search up the papers on, something like Google Scholar, or, on the journal, and I can see, oh, is the journal real? Is this article real? And it's like, it saves me a lot of time from having to find doing all the search to find the article, and then verifying that the problem is correct is super simple. I don't know. That's kind of what I consider to be this fundamental problem with AIs and LLMs right now. We fundamentally don't have a way to settle this, because they're just because of the probabilistic nature. Like, we would need some kind of model that is reliable in a way that doesn't have these, oh, it's probably correct, in order to really get past this problem, right? This is more like a modality problem, right? The things that it gives you aren't necessarily correct in certain contexts. They're probably correct in all contexts. And the only time it's excusable is when the concept of being probably correct doesn't matter or doesn't exist. But yeah, that's basically all I have to say about this. If you're interested in other things, if you're Gen Z in STEM and you also like games, make sure to subscribe and keep watching these videos, and definitely supports me. And I really like talking with you guys about sort of your thoughts on these sorts of things. So yeah, feel free to comment and let me know what you think. All right, peace.